Hello and welcome back to Compiler Programming. Today I'm gonna start out working on a next big feature, which is support for floating point numbers. And this can be a bit tricky because they use different registers. You can't easily transfer them from like one register to another in the same way that you can here, and there are other limitations. Also, they require larger instructions to be encoded because they are essentially using the same registers and the same setup as SSE or SIMD instructions. There is a bunch of stuff that has to be done for support for floating point numbers. But we're gonna start pretty easy. So the goal for today will probably be to define a floating point single precision, so F32 number on the stack. Define two of them, load one of them into a register, and then try to, I don't know, sum them or something like this. Even that might be a bit too complicated. So let's see how it goes, but we have to start somewhere, and I guess I will need to start with the encoding stuff. So, operand type. Well, we have definitely need to have a new operand type, and I wonder if it is a new operand type or just new type. I think it is. So at least as far as the registers go, this is not a general purpose register like this one. So probably we will need a new operand type. Maybe we should start from the instruction side of things and go from there. So we have this stuff here. These are just helpers. We have register stuff, and which is defined actually. This defined here. So yeah. I wonder if I want to put it in the same enum or into a different one. Because from my understanding, XMM registers have the same sort of setup where they are from 0 to whatever, 7 maybe. And they encode that in a similar way as to here. So let's just look at the instruction. So we have this move SS, which is an instruction that either moves between two registers, or it is an instruction that moves from a memory to a register. And even though they say like XMM1 here, from my understanding, I can encode any XMM register and any like in here as well. So if we move to this stuff, so I can have this XMM3 and XMM4, whatever, and I can do XMM0. So I'm not sure why they just show one instruction, maybe for conciseness, but this seems to work. Anyhow, looks like the first thing we have to do is actually support 3-byte instructions. So let's start with that. Okay, so opcode right now is expecting to have just 2 bytes maximum, and that means that we need to extend it. So where's our opcode? Yeah, so opcode is 2 of these. And I guess it needs to be, well, let's make it 4. I don't know if there are actually more bytes and instructions. We can also make it 3, but doesn't really matter, I guess. Okay, so how would that look like? Well, we need to start doing these kinds of shifts even more. Let me try to figure out where does it need to go. Okay, so I guess I will make it multi-line so it is slightly easier to understand how all of this functions. And then we can see that we can take this stuff and we can just put 16 and we can put 24. So now we should be able to put here something that is up to 4 bytes. And the reason we are flipping around bytes over here is because we want in our code to look like it looks like here, right? So that we can just copy these bytes straight out of the reference and use them and not have to flip them around for little endian format. Okay, so that should still all work. Let's just verify that I haven't messed stuff up. And it looks like I did. Yeah, right. So they are in the wrong order now. So maybe I should actually make them. Let me quickly think about that. So yeah, I just need to change stuff over here. Opcode, and this is now 4. And I can say that it's, well, I guess I have to do it the hard way. Because it doesn't want to assign arrays, if I remember correctly. Okay. And where we are doing this, we now have to sort of extend this stuff where we say if opcode 1, if opcode 2, and then opcode 3, 2, 1. Okay, let's see if that works. Test. Okay, so that is better certainly than it was. Am I still doing something wrong? So we are getting opcode out of the instruction. Why am I actually using this stuff? I don't really need it. I can just probably use this directly, right? Okay, so yeah, this is why it fails. It's because we have this type of encoding where we add the register directly to the opcode, and in this case we expect that all of the other stuff is actually 0. Okay, now looks good. Let's try again. Okay, we can commit this on its own. Episode 102. Support 3 and 4 byte opcodes. Okay, that is the first thing. Now we are ready to start putting together the instruction. We have move sx, so let's probably put it next to it because it's called move ss, which stands for move single precision, scalar single precision. Okay. And yeah, so move ss here as well, and here. And the opcode is F30F10. Okay, that has /r extension, and it is expecting what? Well, so if I understand correctly, if I put memory on this side, then it will be a different instruction. So let's say I put rux here. Yeah. So that means that on the left, it would expect XMM32, I guess. That's an interesting question of how I should encode this stuff. Should I just call it XMM? Don't know. Let's start with a more simple version and maybe we extend it later. Okay, so XMM, and on the other side is also XMM. Or we can also say that it is on the other side is actually it's like RM but in XMM version. So maybe it would be better to indicate somehow in the whole instruction that is an SSE instruction. I don't know. Let's say maybe I will call just X. Should I call it like this? F32 maybe? No, F32 is already a type, so it will be very confusing. XMM M32. Okay, let's make it like that. Because this instruction can go from to a register, from register or memory, but special SSE registers. And then, so can also split them up so it is easier to deal with and say that, okay, we have here M32. Yeah, I guess that is better. And then we have reverse, which sort of doesn't really make sense to have a different encoding for this one. But it's the same as with others where we have RM and then we have, so it's basically the same as here where we have a pair where on the left side is RM but also is R. So it is like this, and then we say M32 XMM32. So this is what it looks like. Okay. Let's try to build that. First is this stuff. I forgot to rename a few things. Next, obviously it has no idea what XMM32 is. So let's try to figure out what that would look like. So let's take this and we say XMM32 encoding type is so we have encoding types here, and let's say should I call it SSE or XMM? Let's call it XMM. Okay, so this is what we will put in here, an operand size 32. That will generate a bunch of other issues because, or maybe not. I guess we are not anywhere switching on this, but let's undefine it so we don't pollute the rest of the program with this definition. Okay, so we have this stuff, which is great. And I think the very first test I'll try to do is to try to encode move from a register to register, and I don't care that there is actually an initialized stuff in there. I'm just interested to see that we can encode something that looks like what we want. So how would I test it? Well, we would copy a test, and then I would say should be able to encode loading and storing F32 values, and then we will just try to figure out what that would look like. So as far as instruction goes, right now I will not make it return float. I want just to have a single instruction there that is doing the right thing, and I will not even wrap it in move value. This is a whole other thing that we need to deal with. So push instruction builder move SS, and here we need to create this operand, right? So operand XMM0 is type operand type, well, I guess I will have to say XMM, and then for, I guess reg will be fine to use as the actual value. Let me check. So where is our operand encoding, operand size, operand register reg. Yeah, I mean, that's fine. We will have to put them here. And as I said, I think they are exactly the same registers going to here. So maybe I'll actually copy this stuff, replace this as 0, 0, 0, 0, 0, 0, 0, 0, and XMM 0, XMM 1, and so on and so forth. Two, three, 4, 5, 6, 7. At least I think that's how it is. We'll see. So getting back to our test, we say that our register is XMM0, and this is going to be our operand 1, then we have xmm1, and then we have this here. We have this as argument, and that's all we need to do, where we do it like this, and hopefully our tests will pass. Operand type, didn't I add this? Operand type, oh yeah, I actually haven't. Well, that's fine. Okay, that now complains here that it is doesn't know what to do, so that's pretty easy. Bits, byte size, yeah, that's fine. Okay, so we are able to build. I will open up debugger right away and to see what is going on in the generated assembly, because this is totally new territory for me. I haven't done SSE register encoding previously, so let's see how it turns out. Okay, we need this stuff. In fact, I think I will split it in two so it is easier to check. I'll say S32 result is whatever, and then result is 32. It's just so that it's easier to jump into this assembly. Yeah, right. It doesn't, of course, it doesn't work because we haven't changed the encoding thing. And the encoding thing is as follows. We need to add 32 bits. So the sizes are checked above. That means that we just need to say if operand type XMM and operand encoding type is XMM, then we are happy. And the rest, funnily enough, might just still work because it is the same mode around, the same stuff. And I'm using the same field for register. I guess where it will not work is with Rex stuff. Yeah, there is gonna be a bunch of stuff with 64 bits, so with doubles. But I don't know. Maybe that's fine. Let's do it right away. If operand type is operand type XMM, then what? When does this set? I already don't remember. So if instruction extension type is register, and instruction extension type. So for now, I want to be as specific as I can, and then relax these requirements later if I realize that they are too strict. So we have XMM register, and the extension type is register. And another thing is we have to check encoding uh, instruction encoding type XMM, I guess. So if all of that is true, then it is basically the same stuff as happens here, except there is nothing about Rex in this case, I guess. So we would set this reg or opcode, and then that is where this is used. It is used here. Yeah, so it is put inside mod rm. And then the other part is happening inside of mod rm, which is here. So if it is a register or memory, then it goes into this stuff. So I guess here I will need to say if operand type is operand type XMM, then I also do something else. And that something else is again like here, but we are not doing the rex things. Instruction encoding type XMM. What did I do? So this is operand encoding type, I guess like that. Coding is not a member. Okay. It's operand encoding. No? Yeah. Something like that. Let's see what happens now. Well, it still says did not find acceptable encoding. That is fine. Let's try to break on the right place. So we have our function spec, right? We have this stuff here. So I guess it will happen on program end, and it will be one of the first instructions to happen. So, okay, 5, yep. Now we go to encoding and we just start breaking here. Oh, I'm not setting the byte size. Does that matter though? Okay, let's check that. Yeah, so here there is size. That means that in the actual test, I also need to be saying byte size is 4. Okay, let's see if that is any better. F10. Okay, it looks like we managed to encode something. Let's see how bad it is. Well, apparently, yeah, it doesn't work. But that's already an interesting thing to look at. So we have sub RSP and we have move it as XMM0, XMM7. Well, one of them is correct. Now the question is, why isn't the other one correct? Let me quickly check. In here, no. This actually in here. So let's verify that that is fine. Okay. So these look fine to me, if I understood everything correctly. And we were able to encode this stuff. So first of all, our instruction is way too long for what it is. That is the first problem. So let's deal with that. Or maybe it's not long enough and C7 actually comes from the other thing. So what I want to do now is probably break inside of here, maybe. Yeah. So we are on the zeros operand. This is exactly what I would expect. So we say reg or opcode is register, which is 0. At least that's what I would expect to happen. Yeah, reg or opcode is 0. Everything is fine. We go through this stuff. And now we encode the second operand. Its byte size is not that. And we will not go into this thing. We will not go into this. This is wrong. No, this is actually correct. How does it work for other instructions? I'm a bit confused at my own code. So we have this stuff. Okay, let's just try to go through this and try to understand how RRM actually works like here. So we first encode the register. Operand encoding type is register. Okay. I think I understand what the issue is. So I can't actually do it that way. I have to do this way. Otherwise, my logic does not work. So I have to create XMM M32. XMM M32, XMM M32. I'll think about it off stream and maybe there is a better way to do it. But for now, I just want to make progress and actually have this working. So this will be a XMM memory. That means I need to add this encoding type into our setup here. So there's gonna be XMM memory. Let's see what else is necessary. Okay. And then here, yeah, now it will not drop into this stuff. Instead, it will go into here. Okay. That seems fine. And here, by the way, it's missing some stuff. To do mask the register. And here, mask RM, I guess. Well, here it's not really important to mask RM, but okay. Getting back to our stuff. So now this should go into this branch and actually put it in the right place. I hope. Let's see. Where did it exactly crash? Okay, it did not find acceptable encoding because I now need to do this. I need to add XMM memory, and then I need to say operand type memory and XMM memory. Isn't it? Operand type memory. What is it called then? Operand type, memory indirect. Okay, that should be better. Let's run again. Well, so this is our first now. Let me go through, and then we should skip over this. Yes, we are. And I forgot to put this one here. So another thing to add is now we need to say that you can put XMM memory in register memory in the modrem byte. Okay, next. Again, skipping over this and go here, and we should go inside of here. Yeah, we do. We now skip over this. We realize it is XMM. We add it to RAM. We say mode is register. Everything is fine. We don't have any more operands. This is the next instruction, I think. Okay, we don't have rex bytes, we don't need prefix, we don't have this one, but we do have 1, 2, 3. We need modrem, we encode modrem, we should not need sieve, we don't need sieve, we don't have this stuff, we should not have any immediates in our code, and that should be the end of the instruction. Okay, so that feels good now, at least as far as I can tell. So we are ready to actually look again on the disassembly of this thing. Okay, that looks much better than before. We don't have any extraneous bytes, and we actually are encoding the right instruction. So let's verify this with this encoding, and we say that I want to move SS, XMM0, and XMM1. And that is exactly the bytes that we are looking for. So that is pretty good. Okay, let's continue then. So I will try to step through this, and everything seems fine to me. So it doesn't crash, it's a correct encoding, and we are happy campers. Let's commit that separately as well. So git commit episode, I think it's 102. I'm actually already don't remember my own episodes, but it's fine. Episode 102, encoding of XMM registers in I will just say moveSS or R instruction. Sounds good. And now it becomes a bit more complicated because we need to, if we want, I'm just trying to figure out what would be the simplest thing I can do here. Because if I want to return that value, then I need to open the whole can of worms about calling convention, and we need to propagate through there, and that's gonna take a bunch of time. So let's just maybe it's not a simple thing, we'll just add another instruction, verify that it also works, and that would be all for today. So I'll copy these, and I have add, and there is, I believe, add SS. So this is what we can try. So we can have add SS happening. Okay, so from my understanding, this is the code F3OF58. So it looks like this is just a prefix that is just sort of always there. So maybe we can more efficiently encode this later on, but let's see if that happens. So my guess is this is what it will look like. That actually is wrong here. Where's my moveSS? Oh no, this is fine. Okay. So this is just my guess on the 59, but we can verify it now here. Just say add SS and have this thing not being able to find it for whatever reason. Let's just go to the top. I think there is a list of instructions. Yeah. So there is add SS, and it is okay. So it doesn't actually have the other mode. Maybe. Seconders and stars double precision floating point result in the destination operand. Yikes. So that's interesting. So does that mean that I will have to convert it to... Okay, I'm very, very confused. So I do x plus x, and it just stores it and it just returns. So it is saying that the precision is the same, But here it says that it basically results in double precision. So I'm not exactly sure what is happening. I will need to look at the instruction more thoroughly, I guess. Maybe that description is not correct for SSE. I don't know. This is weird. I need to figure this out, but for now, let's just say that this is how it is. So we can try to do this now. And SS. Nothing really will be different. But right now I'm just testing that our encoding works, not that we are doing something very useful with this, because that's the big thing will be updating the calling convention to support this stuff. There will be all kinds of stuff around moving and stack reservation and all of that. Okay, so let's see the encoding. Disassembly, step inside, and it did not work very well. Ah no, this is junk. This is fine. No, everything is actually okay. And this is move SS. Okay, so this is fine. Can we look at these registers? So if I enable SSE registers here, then maybe I should dock it like here or something. Yeah. So all of them are 0 because we did not put really any value in there. So we can't really see what happens when we do add SS or move SS. Okay, that is fine. Let me think about if it will be possible to quickly try to put some value on the stack or not. I mean, I don't actually have to do it right to make it happen. So I will do some pretty nasty things right now, but they should allow us to make some progress. So here's what's gonna happen. I'm gonna put a value on the stack, and that value will be S32 from the standpoint of C, but in reality it will be F32. So I will do 420F. I will convert it to void star, and then or how do I do this? Because I basically want to reinterpret 42 as the float. So let's just say that F32 is F is this. Then I'll take an address of F. I will cast it to void star. And here it's a S32, F32 as S32 is this. So I turn it to void star, then I turn it to S32 star, and then I just say star. So now we have bits of the floating point number, but from C perspective, it is a 32-bit number. Okay, so we have it here, we have it on stack, and we will call it test very unimaginatively, test F32. The whole point is I want to have something in the memory so we can test this. Test F32 operand, I guess that's how it goes. So let's see what happens now. Yeah, I forgot F32 as S32 here. Okay, we are not using XMM1, that's okay. Okay, it builds. Let's see if it encodes and if it runs. Okay, so it encoded to something that is already good. Now the question is, did it encode to the right thing? So let's see. 11. Okay, so that looks pretty good, I have to say. So we are moving this weird number, but as I said, it is interpreted as should be interpreted as float while it isn't here. So let's see if that makes sense, and we can look at XMM0 after move, and ideally it should be a floating point number. I'm actually not sure if it will show anything useful here, because the way it shows XML registers is just bit patterns, and I'll have to. I'm not sure how to look at it correctly, to be honest, but that's fine. Ding, ding. Well, at least it didn't crash or anything. Maybe there is a website that we can look at and say floating point encoding online or something. Okay, let's go to Google. Okay, we have this converter. Okay, so I want 42. Okay, yeah, that looks correct. So we have 422 whatever in XMM0. So that works just fine. That means that we can have now operations that deal with two XMM registers and with XMM register and memory, and all of that seemed to work just fine. That is a very good base for us to continue in next video with more support of floating numbers. But today, that's enough. Thank you very much for watching, and hopefully see you then.